Okay, so here's another example. In this case, we're going to be using a different conversion factor. And for this conversion factor, we are going to want to remember or understand that for every 1 mole of any substance, no matter whether it is an atom or a compound, 1 mole of any substance is equal to 6.02 times 10 to the 23 particles. And by the word particles, we mean either atoms or molecules or formula units, whatever we have. So we're going to use that for our purposes of being able to solve for our number of atoms in this case. And so we also have to remember that if for this one, this is an extended calculation, we are also going to remember that 1 mole of any substance is equal to its molar mass. Okay, and as we just practiced with the last examples. So that means that we are going to need to use molar mass as well. And we are going to set up a calculation so that we can not only calculate moles from these atoms, but then go on and calculate, moles from these grams, but then go on and calculate atoms. So in this problem, we are asked how many atoms are in 23.98 grams of potassium, and I have underlined our thing that is given, and I'm also noticing that it has 4 significant figures. So that means my answer is going to be 4 significant figures. All right, so that means I was given 23.98 grams of potassium. Okay, so that means that I am going to have to set up my calculation again so I can calculate moles, and I'm going to want to know what is the molar mass of potassium. Okay, so I have looked it up on my periodic table, and the molar mass of my potassium is found to be 39.10 grams per mole of potassium. So that means that I'm going to set this up as 39.10 grams of potassium on the bottom and 1 mole of potassium on the top. And if you remember, please, that is so that we can cancel out our grams. All right, do you see me adding another section? For this section, once I have divided by the grams and canceled out the grams, now I'm going to have, if I stopped my calculation right here, I'd be solving for moles. But I need to solve for atoms, and I know this relationship right here, that 1 mole is equal to 6.02 times 10 to the 23 particles, in this case atoms. So 1 mole of potassium is going to be equal to 6.02 times 10 to the 23 atoms of potassium. Okay, so now if I were to just calculate right now, I'd be concerned that I was solving for the right thing. So let's make sure we can see that our units are canceling. My grams of potassium is getting canceled with my grams of potassium. And my moles of potassium is getting canceled with my moles of potassium, leaving me atoms of potassium, which is exactly what I want to solve for. So now I am going to do my math in my calculator, and I'm going to determine the answer. Okay, so when I have put that all in my calculator using, yes, scientific notation, and yes, we are going to talk about exactly how do you put scientific notation in your calculator, I get this number, 3.690206. And I'm going to stop with the numbers there because I know that I have to round to 4 significant figures, and that gives me enough information. And it says E23, so that means it's 10 raised to the 23rd power. Okay, so I need to round, remember, to the 4th significant figure. So this is my first significant figure. Here's my second one. Here's my third one. Here's my 4th one. That means I'm rounding between the 2 and the 0, and that means my 0 does not round the 2 up. So I have 3.692 times 10 to the 23rd atoms of potassium. And that is my answer.